This is our last video for your project. So this last video is going to show you guys how to calculate tree heights. Now we are going to be using a raster data set to do this, and because it is the best way to do any kind of analysis. So going back to our catalog, we have all these different services that we created in the previous one. So I'm going to bring in my raster data set because that one I used my elevations for. And I also used an average elevation. So I'm going to, and actually before I get too far ahead here, I am going to be giving you the methodology, but not the actual options to do this correctly. So if you follow this video and you do exactly what I say, you will get 1 mark out of 2. If you go through and you think about what I am teaching and what I am doing here, and really what the purpose of calculating those tree heights is, then and how do you actually get those tree heights? If you see errors like that I am teaching here, I have put them in there purposely. Okay? And the reason for that is because I want you to think about the options. What option would I choose to be able to calculate a tree height in this case? So, so starting with that though, so I have this model that I created last time. This one was used with a 5-meter resolution, and it was made with spatial resolution, and it was made with average heights, so the average height within the actual pixel itself. So we can assume that if we look at the two of them, and let's say we zoom in here. Switch it to that. Okay, so as we zoom in, if I turn this on and off, so we can see how the points have been created. We can see where each pixel is. So if I zoom in even more, so let's say we're looking at these pixels here. How many data points do I have in each of those pixels, right? So we can see that, for example, here, if I were to count them, there's quite a few points per pixel in there. So that's fine, and that's okay because honestly, if you look at the overall result, it doesn't look that bad for because of the area and the spacing that we're dealing with. So now that's for buildings, but what about for trees? Does it make sense to have that kind of resolution? And now what are we actually really looking at? Are we looking at the entire crown of the tree? Or are we looking at individual locations within the tree? So these are a few things I want you to think about. So I'm going to use this one as my DEM, or my original kind of surface model that is including all of the values on top of it, okay? But I now need to create one that is a that brings it down to the ground. I want to remove all of the trees, and I want to find just the ground. So one of the neat things here is we can just say ground, so we can switch the filter to a ground filter. My last data set, so there, right? And so that's ground, so we can say, okay, maybe that filter is what we want. And then I'm going to change my search to last data set to raster, and I am going to find my raster option. Now I'm going to input my last data set. I'm going to call this my bare earth model for the project. It's a raster data set. Hit save. My value field is going to be my elevation. And my binning this time around is I want the minimum value. So I want my minimum elevation so I can get the ground. I'm going to use linear to fill in. And my output data type is going to be float because I want decimals. My sampling type is cell size. And I want to keep it the same as the other one because if I change up the pixel size, then I'm really not comparing the same thing. So I'm going to keep it the same as my raster data. And then I'm going to press OK. All right, I'm going going to turn this one off, and there's my bare earth model. So this one does not have buildings in it, right? Let's say I were to change this symbol. And I wanted to change it to some more color. Look at that, no buildings in that, which is perfect. So now I can get rid of the buildings, and I can get rid of the trees, and I can find what's actually on the ground. So this is perfect, right? So I now have those two that we have together. So I have my average height, and I have my minimum height, so my actual minimum value. And now I want to take away the trees, and I want to just figure out what the height difference is, right? Because I didn't ask for the elevation of the trees. I'm asking for the height, the average height. So I need to remove the elevation. So looking at these, my raster data value has highest value of like 1100, and my bare earth model highest value is 1093. So what I'm going to do is I'm going to subtract one from the other, and that's going to give me a height that's relative to the ground. So in order to do that, I need to go to the raster calculator. So there is a raster calculator here. This is what we're going to use because this is where we get to do exciting stuff. So this is really picky, so only use the buttons. So don't type anything. So like we said before, that the raster data value is higher than the bare earth model. So I'm going to double click on raster data, and I'm going to hit subtract the bare earth model. So now I have those two subtracting each other. My output raster data set is going to be my relative heights, right? So it's relative to the ground. Oh, I didn't like that. So what? The length of the grid name is too long. Okay. So we're just going to call this height. There we go. It's picky, like I said, it's very, very picky. So we're going to call this one heights and press OK and let it process. There we go. It looks like a pretty accurate model here. So we've got, like, we can definitely see the trees on this side. We can see where the buildings are and see the soccer field and everything else. So this is great, but we need to think about what is a building versus what is a tree. So there are ways to look at this in terms of the return value. You can also use other features to do this to be able to identify them. I'm doing one way, and you're welcome to do it this way. If you do find another process of being able to do this using number of returns, I'd be very excited to see that, because it is a lot more complex, that process, to be able to identify it that way, but it is a lot more accurate. But I'm just showing you guys how you can do analysis using rasters. So, and just trying to keep the process simple as we go through. All right, so we have our heights. We know that we have everything from 66 to negative 100. So obviously negative 100 has to do with this error up here. So we want to get rid of that. We don't want that to be a part of our calculation. We also don't want buildings to be part of the calculation. So obviously these buildings out here are not going to help us any. You're welcome to change the size to just the SAIT campus, so you can get rid of all of these. There's a lot of things that you can do to try to limit errors in this calculation. Those parts are more for you to play with if you were really excited about doing stuff like this. For those of you who just want a process to just how to do it, then you're welcome to follow along, right? So our next step then is, so we have heights. Now we need to figure out what is in between those heights. So let's say we need to figure out a minimum value of trees. So I would say that a minimum tree height on SAIT campus is probably 3 meters. There might be some that are a little bit shorter, but most of them are at least 10 years old. So they're certainly taller than me, and I'm like 1.6 meters, and they're certainly taller than 2 of me. So maybe even 3 meters might be a bit short, but I'm going to go with 3 meters. So I need to determine anything that is above 3 meters, right? Because it has to be higher than 3 meters. So I'm going to go heights, and I went back to the raster calculator. So I'm going to go to heights. I'm going to double click that. Then heights need to be, do I want greater than or greater than equal to? I think I'm going to go with greater than, because I thought that maybe that might be, 3 might even be a little bit low. So I have heights need to be greater than 3. Then I'm going to go to output raster, and I'm going to say, I'm going to call this my tree min. Let's hopefully that's not too long. And then press OK, and it looks like that's going to be all right. So there's my tree min. So I have 0 and 1. So 0 means false, 1 means true. Anything that identified as a 1 means that it is greater than 3 meters. And then identified as 0 means it's less than 3 meters. So now I have to figure out what would be the maximum height of the trees that are out there. Do I think that they are 66 meters? Probably not. I could go to a website and figure out what the height might be, and that could help. But let's say 30 meters. I'm just going to throw out that number. That's with like 0 educational guess whatsoever. Just guessing from like the size of the trees and just, hint, hint. Right? All right. So let's go heights, and this time around they have to be less than 30 meters. So now I've defined what the height of that tree is, and so this is going to be my tree max. So I'm now creating this range. I'm creating this two binary files that one says this is greater than, and the other one says it is less than. So here we go. So anything that was greater than 30 meters is showing up as 0. So we can see that it got rid of these buildings. It's really okay. That's fine. So, so we got rid of those ones. So, maybe 30 meters might have been a bit high, but yeah, we'll just go with it. And then now the next step that we need to do is actually create a binary file that shows the two of them together. So there are 2 different ways of doing this, or actually more than that. So we would have to sit there and look at like the basically a matrix or a table of what does binary look like. So if I add these 2 together, if I add the tree min and tree max, I'm going to have anything that is true is going to be a value of 2. Anything that is only true for one of them will be a value of 1. And anything that's false for all of them, it's going to be a value of 0. If I subtract, I will end up with a value of 0 if it is false for both of them. I will end up with a -1 possibly if one of them is false. And if I subtract them, I will get 0 as well if both of them are true. So that subtracting doesn't work. Now, what if I multiply? So if both of them are false, it's going to be 0. If only one of them is true, it's going to be 0. But if both of them are true, then it's going to be 1. So I would say multiplying is probably the better option. So now we're going to go to raster calculator, and we're going to go tree max, multiply by tree min. And then this one, I am going to refer to this as trees only. I'm going to hit save and OK. So let it think. There we go. Now, obviously, we're having issues, right? So my algorithm is not working correctly because I have buildings in there. There are many ways of taking out these buildings. There's cropping ways. There is taking your buildings that you created in part 1, right? You had to digitize all of them. You can cut them out that way as well. You can change it with filters. There's a lot of different ways to approach this, but making sure that you're kind of keeping track of that as we go. So, so now we have a trees only binary file. So anything that is 0 means it is not a tree. Anything that is 1 is a tree. So going from there, I need to figure out how to put together my trees only, which is a mask, because that's really what it is. A mask has 0s and 1s and says, yes, operate on these areas, do not operate on those areas, with my heights, because then that's going to give me that should give me my values. So now I can skip any of these raster calculator parts, and this one I'm going to actually follow through directly, so there's going to be no errors in this because this is a kind of a special step. So Zonal Statistics is the name of the tool that you're going to use for this, and so you're going to click Zonal Statistics. Now the input raster feature zone, this is going to ask you for your mask, right? So we're going to choose the trees only mask. And the field is value, right? Because we're looking for an actual number that is going to come out of it. Then this is the value raster. So this is my heights. So the heights is going to come through only for the trees. And then we're going to get a weird raster, so this is a stat raster. It honestly, you can call it whatever. You are not going to show me it because it doesn't matter anyways. So my statistics type is, of all the values that are true, what kind of statistic do I want? Well, I do want a mean because that's what I'm asking for. I'm asking for the tree average. I could ask you for what's the highest tree, the lowest tree. I could ask you for the range of like what's the lowest value to the highest value. Now, obviously, these ones are going to be limited by what you put into into the raster calculator, right? So you're going to have like your maximum value is going to be 30, your minimum is going to be 3, the range is going to be 27, right? So there's that. You can also do standard deviation, and you can also add up every single pixel. So lots of different statistics that you can do. We're going to just ignore no data. We don't have any of those, but we can ignore them. Then we press OK. So now what this is going to do is going to give me a range. This is your standard deviation. This is your value. So I want you to, this is the value that you're going to give me for this, this tree heights, okay? If you want to tell me standard deviation, it's fine, but you don't have to do that. This image, obviously don't give that to me because it's black. So, because it's showing me all of the standard deviations. So don't do that. But this is the average value, which is a 7.86 in my case, in what I have calculated. So the zonal statistics is correct, that there's no error in what I was showing there. There are some things that you can do to fix this. So the value should be over 9.5. If you can get it over 9.5, then you're going to have a better chance of getting it correct. Okay. So that's just kind of giving you a bit of a heads up on that. Like I said, there are many different ways that you can do this. You can crop the area. You can adjust how we did the heights, right? So, you know, when we created the very first rasters, did it make sense for me to use the values that I did? So, you know, what about the cell size? Does the cell size make sense? What about the type of binning? Did that make sense? Did it make sense how I was adding and subtracting? Did it make sense about the tree height values that I was coming up with? So those are just a few hints to look at and consider what I have done. But in the end, you're going to end up with a value, and you are going to provide me with that value. And that is how you can do tree height analysis through ArcMap. So just kind of a fun thing that you'd be able to go to industry and be like, hey, I learned how to do tree height calculations using LiDAR. And this is only one way. Like I said, if you can come up with another way, fantastic. You don't have to, though. Like, so that it's just honestly, like, if you're really excited about it, go ahead. So I hope that you will explore different ways of doing this, because really, like, following through what I just did is really easy. But I do want you to explore different ways. I want you to explore different options. This particular part of the project is pretty low key, but I want you to show some critical thinking in this part. So think about it, research, try to find what you can do. So that is everything that you're going to be needing in your project from all the previous examples. And from there, during class time, if you are watching this before classes or before the classes I talk about anything, we will be discussing more in class about what my expectations are for the project.